Hello everyone, welcome back and as usual with another Pizza Time episode. Here we are again with a new video tutorial, just like we saw for the circular ovens mods. Also in this case it will be the first video guide ever done of this type. Today we will be doing what I think is the definitive modification of the Effeuno pizza ovens. In fact we will be installing a PID, in my case I will do the mod with my P134h and I'll be using a Smartpid, but as we will see the logic will be obviously the same for all similar PID controllers or ovens. We already talked in other videos about the benefits of the PID controllers. PID stands for proportional, integrative and derivative, which are widely used for several purposes. First of all, we see it being used in industrial applications, but there are also several home applications such as homebrewed beer or BBQs, and as we see for example with the Effeuno Evolution oven or other professional and very expensive pizza ovens, we would have considerable advantages in using a PID controller also in our domestic pizza ovens. In short, the advantages of digital thermostats compared to the standard ones will obviously be a much better baking result due to a fast and stable temperature control and a lot more precise. Therefore, this should also guarantee a consistent result over time between the various pizzas we will be making. Obviously, many people out there have already completed the modification of Effeuno ovens with a double PID configuration, and maybe also with a third additional PID at the center that acts as a timer. But today we will see what for some aspects is the evolution of all these PID controllers, capable of managing with a single device both heating elements. It will also act as a timer, it allows us to save custom profiles and much more. The PID we are gonna review today is called Smartpid. It's an all-Italian project born a few years ago through the Indiegogo crowdfunding platform. The founder is Davide Arzanello, who was kind enough to send me the M5 Pro model that we will see in this video. You can find the link in the description at a price of around $230, to which you have to add the shipping costs and the K thermocouple adapter. But thanks to Davide, we managed to get an exclusive discount code for the subscribers of this channel. So using the coupon code you find in the description below, you can save about $35. We are talking about an Arduino based PID controller designed to automate manufacturing processes and with a current generic smart thermostat application, which is meant for general use on all types of ovens, furnace ovens, beer fermentation cellars, or even industrial processes, we can anyway obtain excellent results even with pizza ovens. With a single device, there are two independent channels with a top and bottom temperature and or power control, baking profiles, and also other functions. I'd like to specify that the Smart Pizza project is currently in standby mode due to other priorities. We therefore have a firmware which is still at early stages and still to be improved for the specific usage of pizza baking. But don't be mistaken, however, because this is not a prototype at all. It is in any case a finished and commercial product already sold since a while all over the world. The final firmware should arrive in January 2022, and once ready it can be installed in our PID directly via OTA, therefore via Wi-Fi, or if you like you can also use the integrated USB connection. As I repeat every time in my videos, also in this case we are going to perform a risk modification which invalidates the oven warranty and which you do exclusively at your own risk, so rely on more experienced hands if you are unsure of what you're doing. In the video you will see first of all a quick unboxing, we will analyze the specifications of the Smartpid, and we will then be looking at the shopping list necessary for the mod with related costs, and then obviously the installation and various baking tests at the end of the video. I warn you that however this will be a very long video due to the complexity of the mod, but also due to the numerous steps we have to take, and as you know I always aim for the highest video and content quality, so the details I speak about will make the video probably even longer. Anyway, you can find the chapters below as usual for quickly switching between the various topics. But now without further ado, let's start immediately with the video. Okay, now let's do a quick unboxing of the Smartpid, and then we will see the remaining components required for the mod. On the side we can read the product revision and the version of both the hardware and the software. Continuing with the unboxing, we find the clamps and supports for mounting the PID. In this little box instead we have the SSR, which means solid state relay. Here we have a dual channel version, since it will have to manage both heating elements, and I prefer it because it makes wiring and installation easier. But if desired, it is also possible to install different PIDs, like for example 2 single channel ones. As we can read, this is a 40 amps SSR, so as we will see later, we need a proper dissipation for it. And we complete our unboxing with the Smartpid M5 Pro, and we can immediately see how compact it is. The first thing that catches my eyes is obviously the display. It is a 320 by 240 pixel TFT color display with menu and interactive graphics interface. And we can also see the 3 buttons for interacting with the graphic interface. On the side we have an I2C serial expansion port, a USB-C port and the reset button. Here we can see the slits of the integrated speaker and also a very useful microSD slot for logging our data, for example. Here I'm gonna showing you the other main specifications, including the 2 independent control channels. Therefore it is possible to connect 2 thermocouples which act in a totally independent way, one from the other, being able to read the temperature values at any time and also remotely. In fact, the Smartpid connects to the home Wi-Fi network and sends the data to a server. The data is then accessible at any time from any smartphone or PC using the web app. As already mentioned, the firmware can be upgraded via USB or OTA, and we will also have an internal memory that allows, for example, to keep the data in case of a blackout. Regarding the dimensions, I measured 5.4 by 10.4 centimeters, while as we see the total weight is just 132 grams. Now let's recap what we need for this mod. In addition to the Smartpid and the SSR that we have already seen, we're gonna need 2 thermocouples of type K, M8, 0800 Celsius and 1 meter. The lower one will be 50 millimeters, while the upper one will be of 100 millimeters, and it will need to be folded at 90 degrees. The lower 50 millimeters will be put straight into the original hole that will be enlarged with an 8 millimeters point drill. Also the upper one will also be installed in the same way, and it will be of 100 millimeters. Then, as we see here, we need a nice heatsink for the SSR. There are different types on the market, and usually between 2 and 10 euros. Just take the largest one you can find. I'll be using the black one I have here. I even had a little leftover of thermal pads, but we will see later whether to use them or not. Very important then are the cables, so we need the 14 AWG silicone wires with the resistance up to 200 degrees Celsius. You can also take 5 meters in total, 2.5 meters of one color and 2.5 of another. Obviously you'll also need insulated fasten tips, fasten terminal forks and so on. You can make them yourself or ask someone to do the job for you, just to save time. Like these you see here, which also have all terminals labeled for reducing chances of mistake. If you like, I'll leave you a contact below. Then we will also need a new front plate, but if you do the modification of the 2 PID, then you can also reuse the original Effeuno faceplate by cutting out 2 windows with a Dremel. But with the Smartpid we will have a single PID. You can also try to reuse the original one, modifying it, but I preferred to speed things up by contacting my friend Rosario, who also assisted me in this mod, and in addition to the cables he also provided me with this pre-cut ready to use front plate in 1010 stainless steel with satin vinyl frame, and as you can see here the result is really excellent. Later on we can also apply a custom sticker, as we have already seen in one of my videos. I leave the link between the suggested videos at the top right of the screen. So let's recap the necessary for the modification. The total cost of the mod will be between 300 and 350 bucks. We have an aluminum SSR heatsink, a 1010 stainless steel front panel, or we modify the original one for free, a Smartpid M5 Pro controller, a dual channel SSR, silicone wires with resistance up to 200 degrees Celsius with the 14 AWG section. We need a total of 5 meters plus fastons and terminals. 2 thermocouples type K M8 1 meter, resistance of 0 to 800 degrees of 50 millimeters and 100 millimeters, and then a K-type thermocouple adapter. Now it's time to do the preliminary operations. So first of all we can sign up in the web app just like I'm showing right now, and using the link I put here we could then use the same credentials for the app that you can download for free in the Play Store. And now let's start with the operations as preparation for the actual mod. First of all, we lighten everything by removing the stone you currently have in the oven. Then we move on by removing the screws in order to remove the oven chassis. So after the 2 side screws and the rear one, we remove the 3 upper ones, which are the longest ones as you can see. We pass then on the left side and we remove the other 2 in addition to the rear one. And now we just have the remaining ones at the back of our oven. We see that we have removed a total of 14 short screws and 3 longer ones, which are those of the front. Now we simply remove the rear panel, but we see we cannot yet remove the oven chassis if we do not first detach the fastons from the fan. Now that we have removed completely the case of our oven, we notice several plastic cable ties that will have to be removed. Once we have removed the last plastic cable tie, then we move to the back of our oven in order to disconnect the fastons of the 2 heating elements. Then let's go sideways and also detach the fastons that go to the oven lamp, and we will be doing this slowly because it is a quite delicate area. Then we try to mark these 2 cables because we should reconnect them afterwards. We then remove the 2 probes from the probe stop inside the oven, and we pull them from the outside for removing them completely. As for the upper one, remember you have to remove the first probe at the top, not the one a little bit lower, which is the safety thermostat one, that needs to be kept as is. Once the 2 old probes have been eliminated, move to the front and start freeing up the front panel by removing all the fastons from the LEDs, the knobs, and trying not to damage the insulating wool with your hands. In the end, we should have removed a total of 8 fastons, and we remove even the fastons of the power switch. However, we should mark the position of these last 2 cables because we will need them later on. So here we see that I have already disconnected all the cables, and I also removed all those that we don't need anymore, in order to not confuse us. So in the end you will be left just with the ones you see here, then the cables of the fan and the bipolar power switch. You can also mark them as in my example here. Now let's continue to focus on the faceplate and start setting up everything you need for the new front panel with the installation of the PID. Before the actual installation of the new front plate for our PID, we can stick a custom graphic on it if you like. You can check out my video on the top right corner where I also shared some custom graphics I made for free. As soon as we try to insert our Smartpid into the new faceplate, we see that we first have to remove the 2 rear screws provided. But even after removing them, unfortunately the PID is slightly wider than the opening of the DIN. I solved this issue by filing the right and left sides of the PID as well as the corners, initially with some sandpaper and then with a metal round file. After having filed it enough, it will fit just fine without any resistance. We can then take the supports of the PID, which will be installed as I show here, and I will be securing them with the provided screws. Now we can also put back the 2 small screws that we had previously removed. Once done, let's make sure the PID is stable in its housing and remove the old faceplate with the 6 screws. The last thing we will need from the old faceplate will obviously be its power switch. First of all, let us mark the orientation of the switch. Behind here I read an L at the bottom of it and we see an N at the top. We remove the power switch. This will require some patience because we will have to fold one by one and gently the 4 flaps by pushing the switch from the inside towards the front. Once removed, we insert it in the new front panel, obviously starting from the outside and in the correct position. Then we will have to read an L in the lower part. We can now see the power switch is firmly in place and it also works perfectly if we press it. Then we insert the new front panel in the oven by fixing it with the original screws. Now let's move on to the SSR preparation. We need the heatsink with 2 screws, then the dual channel SSR and the thermal conductor, such as for example thermal pads or a thermal paste. Here we see the example with using the thermal pads. while here we see the installation with an high performance thermal paste with a thermal conductivity of approximately 12 or 14 watts per meter Kelvin. We just put in a small amount, which then gets spread with a spatula or directly with your finger. Be careful to not put too much of it, or it will have a counterproductive effect, just like with the computer CPU. Then it will be very important to tighten the SSR firmly to the heatsink with a couple of screws, in order to make it touch completely to the heatsink. Here you can see that we have a small gap that shouldn't be there. I had to try several screws and finally found some 4x10 threaded screws that fit perfectly with this heatsink. We can now focus on the thermocouple installation, but first we have to enlarge the oven holes, and to do this we need a number 8 point drill for metals. I recommend that you always use gloves for this operation and a face mask, because the insulating wool may fall out, and that's toxic if inhaled. First check the thermocouple location from inside the oven by inserting a screwdriver in order to be sure you are in fact drilling the right area. Personally, I had no problems for the top one, while for the lower one I had to first use a 6 drill bit, then a 7 bit one, and then finally a 7.5 drill bit. Only after that I was able to use the number 8 drill bit. Then we take the two thermocouples as mentioned. The 90 degrees one will be positioned above, unscrew the bolts applied, insert the probe in the enlarged hole, and then fix the nut inside the oven, tightening it as much as possible. The lower probe will give us a bit of a trouble due to the limited space available for the installation, so it will be difficult to tighten the bolt, but I solved this issue quickly with the curved nose pliers. And we see here the top thermocouple will slightly point downwards in order to move it away from the top heating element, while for the lower probe we will try to bend it in order to avoid a direct contact with the lower heating element. I wasn't able of doing that, so I placed a stainless steel bolt at the center of the heating element support in order to raise it. You can probably better see with this shot from inside the oven. The next step is optional, and it might be not necessary in your case, but anyway I recommend that you check this area of the oven to see if you have any insulation problems, like with my Effeuno oven, but also like many others that I have seen. So if you notice dirt due to burned areas, we first proceed with an accurate cleaning. You can also use the cleaning products I suggest in my Effeuno video review. Once cleaned, as you can see here, we must get an adhesive tape suitable for high temperatures, like this one that I show here. And some normal aluminum foil paper, obviously the thickest one you can find. And we will just insulate this area here to prevent an excess of vapors and heat. Then we will take an aluminum sheet that will fold back on itself several times to insulating the affected area. And we will finish the job by fixing everything with aluminum tape, but we will try to use as little as possible, otherwise at the first ignition we will notice a bad smell caused by the tape's glue. Once finished, you should get a result similar to this. Now that we have completed the prep work, we can proceed with all the connections. As we saw at the beginning of the video, there is already a technical diagram placed as a sticker on our PID, and an integration guide is also provided, as you can see here. Once you have assembled the wires, we begin connecting the power supply. So as shown in the diagram, we focus on the section at my left, and in particular in the last two positions at the bottom. Among all the cables we have, we can exclude those with fasten terminals and forks, and we just focus on the Phoenix contacts. Then we take the appropriate green Phoenix terminal block and secure the two cables in the order you prefer. Then we can insert the Phoenix terminal block in the PID, as you can see here. On each of the cables there is an oven light label, so we are going to insert the two fastons behind the lamp, and also in this case we are not interested in the polarity. We position the SSR on the base of the oven, having A1 and B1 on the left of the oven, which is basically the part facing me in the video, and we use the fork terminal cables for the top and bottom heating elements. So as we can see, we will have the lower heating element connected to B1 and B2, while the upper heating element will be connected to A1 and A2. Then obviously we are going to complete the connection inserting the fastons in the back of the oven connecting to the upper and lower heating elements. As for the power switch, it will be very important to pay attention to the two sections to the right and to the left. We will have to insert the fastons of the new cables in the left section of the switch, while the other two cables that we had previously marked will be connected on the right. Here on the left you can see the black and blue wires, which are the new cables we have connected, while on the right we have the blue and the brown that I marked initially. Let's focus now on the bottom Phoenix terminal block, and we will be connecting the black and red cables, alternating them as shown on the manual. Plus, the positive will obviously be the red, while the black will be our negative. The first red and black cables on the left, therefore DC out 1, go directly on the SSR, where we read A+ and A-. Then let's make sure that the cables from DC out 2 are connected to B+ and B-. It's now time to focus on the upper section of the Phoenix terminal block of our PID to proceed then with the connection of the thermocouples. For that it will be obviously necessary to use the K-probes adapter we have already talked about at the beginning of the video. On the left we have TC2, while on the right there is a TC1. So I connected the top thermocouple to TC1, while the lower thermocouple was connected on TC2, in line with the step previously made. We are now careful in respecting the polarity here. The red goes on ion 0, while the other goes on ion 1. Then we can insert the terminal in the PID, and once everything is wired, we can better understand the distances of the cables, and we can then proceed with fixing the SSR on the oven base. For doing that, I have initially made two marks with the black marker, so you can do that after you have decided in which position to fix it, taking care not to obstruct the oven vent slits, nor to keep the SSR too close to the baking chamber, of course. I took a number 4 drill tip for metals, and I created the two necessary holes for fixing the SSR to the oven by using some M4 screws with nut. After a final check on all the various connections we made, we can proceed with closing the oven and connecting the fan. And then we complete our job by tightening all the screws. And here is the oven in all its glory. We are now ready to enter the graphics interface of the Smartpid in order to proceed with configuration. We will move through the menus by using the left and right buttons for going up and down, and the center button to either select or go back by keeping it pressed. For now we can ignore the start and monitor sections and we enter the setup directly. In hardware setup I set the following parameters, especially the core DC and the probes, which obviously must be K-type. We then proceed with the unique parameter sections. Here however I don't think I changed anything, I just eliminated the annoying beep of the buttons. And then we have clock settings that I ignored, since when you connect the PID to the Wi-Fi and to the app, it synchronizes automatically date and time. Then we have process parameters, which is the most important section of the configuration. Here you can see I have already configured the set point, which is basically the temperature we want to reach for both the top and bottom heating elements. In my case, with set point 1, as we saw in the cable connections, we mean the the upper heating element. The lower one is associated with set point 2. Here, as you can see, you can also set the timers. We then have the KP, KI, KD values, which will be set automatically during the auto-tuning. Here you can also choose whether to disable the alarm sound when the temperature is reached, those for the timers, and so on. And this is the section where we access to the auto-tune. You basically just set the channel and decide the temperature for the upper and lower heating elements. Unfortunately, with this PID, it's not possible to perform an auto-tuning with both heating elements at the same time, so you have to proceed with one first and then with the other. On info, then we have all the information you need for the configuration via app to update the firmware and check all the set of information of our PID, such as Wi-Fi status and server connection. We can also create the profiles. The Wi-Fi here is already set, as you can see from the signal bars at the top. Here, very important, you can also choose what type of login to do, if only Wi-Fi or even on SD card. If enabled, you will have CSV files available to inspect later. Here you can check the Wi-Fi status, connection, and even the SSID. After completing the auto-tune that we will see in a while, we can go to Start, which is what we will be using anytime we want to bake something. Let's select the standard and we see the set point values for both heating elements. Once the desired values have been set, go to Start, then on Immediate Start, and then the oven starts warming up. Here we see the set point of the upper heating element and its T1 temperature, while T2 is the bottom probe temperature and the respective set point 2. We see that is going to 100%. With the central button, we move between the various sections. Here we will see the graph that we will be gradually populated with values, while here we will have an overall overview. Now let's move on the monitor. Here we can see the upper temperature T1, and we can turn on the upper heating element simply by clicking on the DC1, which will then go to 100%. Or we can change the percentage using the keys. The same can also be done with the lower heating element by acting on DC2 value. It could be useful, for example, at the beginning to check the correct configuration, so that, for example, when DC1 is activated, the upper heating element is actually activated. Regarding the Wi-Fi and web app configuration, we simply follow the guide provided with the PID. Then let's go first of all to the web app by logging in with the credentials we have already created at the beginning of the video. We will then turn on the PID and we connect our device directly to the Smartpid Wi-Fi network, which will be called Smartpid followed by some numbers. And then, using the password that you see in this guide, you should automatically be directed to a page on the browser, and if this is not the case, you can manually type in the IP that you read here. Then we insert the username and password that we use for the app in correspondence of MQTT connection, then click on the plus to add a new device, and we should only enter the serial number of our PID that can be found from the Smartpid menu by selecting info. Then we select Pro as type, and we have completed our procedure. Now we go with the auto-tune process. Before starting, we must insert our stone to have reliable and usable values. As we will see, what the auto-tune does is to automatically assign the KP, KI and KD values, and therefore to the proportional band, to the integrative time and to the derivative. But the routine used in this PID is very simple because it just sends 100 and 0 and sees what happens, but it doesn't calculate all the intermediate values. However, it is certainly great to have such a feature in the Smartpid since it's missing in other products. For the auto-tune, I will set 490 degrees Celsius for the upper heating element and then 380 for the lower one. Process will take long time because we will see the PWM initially at 100%, but then the percentage will decrease as we approach to the set point. In my oven, for example, I could not reach 490 degrees, but it was always going between 485 and 86. I then quickly opened the oven to measure the temperature at the center of the stone, and these actions we could say has awakened the PID that finally managed to reach the set point. It also went a little further, that's why now the PWM is at 0%. Later it was stable between 485 and 490 degrees, so we should be almost there, and in fact a few minutes later the auto-tune for the upper heating element is completed, and these are the values assigned automatically by the PID. By pressing on save, they will be saved in the PID configuration, but I suggest you to write them down somewhere for safety reasons. Once saved, we modify the parameters in order to proceed for the lower heating element. As said, I configured a set point of 380 degrees and the channel will be obviously number 2. Then we execute. We can see here once again we are almost close to the end, it has almost stabilized, and in fact shortly after we have the values assigned for the lower heating element. Then summarizing, we go back in process parameters and now we see the values have changed, so they have been properly saved. The first 3 they refer to the upper heating element, while the other 3 refer to the lower one. And now we can finally test the oven with the auto-tune values. Even if they can be manually improved later on, we are anyway ready to test the oven, so you will see a rundown of the various baking tests without going too much in detail, since the video is already quite long. I will start with the typical Neapolitan pizza. This is a 48 hours straight dough of hydration, which went a little further. In fact, we have a total amount of 80 hours. Then, in the typical Neapolitan style, I will bake at about 500 degrees Celsius for 60 seconds or less. And here we can see the baking results of a margherita. Here is the result after baking a marinara pizza. Now let's try making a parmesan pizza. And I'm now making a carbonara pizza. We see that for all the dough we got an exceptional speckling and an ideal and homogeneous baking result also on the basis of our pizza. After the straight dough, I wanted to try a Biga. In this case it's a Biga 25 at 68% of hydration. I then lowered the upper temperature to 450 degrees and baked for about a minute and a half. We start with a potatoes pizza. Obviously in this case we have a less marked spotting but excellent baking result at the top and the bottom of our pizza. For the next test we'll be baking 2 frozen pizza dough that I had forgotten for a month in the fridge. In this case we have a Biga 100 dough at 75% of hydration, which will have temperature and baking time completely different from the rest. In fact, in this case I lowered the temperature to 400 degrees, baking for 2.5 minutes. Again, excellent baking with well-cooked pizza and not burned at the bottom. Now a quick test in the pan. It is a pizza stuffed with the escarole. I made basically 2 dough at 80% of hydration and I baked for 15 minutes, turning the pizza after 7 minutes. As you can see, I set the PID temperature at 240 degrees for the upper heating element and 400 for the lower one. And being this a quick test, I didn't change the stone, but I baked directly on the thick Saputo stone, which is not perfect for this pizza style. As an additional test, we can see a Roman-style pizza pan at 75% of hydration. Here I made another one, but this is at 80% of hydration, and you see here I'm using the other stone for better results. Also in this case an excellent result, with a great crunch. As a last test, I finally wanted to see how the oven behaves in case of chestnuts. As you see here, I have set the upper temperature at 250 degrees and the lower one at 300, and here is the result after 30 minutes. I would say we can also consider this test as 100% passed. Finally, we made it! We are at the end of the video. After about 2 weeks of use, I must say I'm super satisfied with this mod and I can finally throw my pyrometer away since it's now superfluous. And I can easily manage everything in real time from the display and from my smartphone. There's surely some work still to be done to refine the values generated by the auto-tuning, but as you have seen from my pizza results, it works already pretty well with all these different types of dough and different baking styles. You can obviously also copy my PID values, but they may not work well in your case because of course you have maybe different heating elements, a stone with a different thickness or mix, and so on. I will try to analyze the data by exporting them in CSV and to improve where I can, and maybe I will then be sharing everything in a new video. I'm also making a list of potential enhancements to be released in the next firmware release. I therefore created a pinned comment below, to which you can respond with your ideas for the next firmware, or simply post your own doubts and suggestions. As always, leave me a like if you liked my work and the tutorial, and also subscribe here to support the channel and for staying up to date on the new videos. Or click here on this playlist to see my other pizza time videos. And that's really everything for today, folks. Thanks again for watching and see you in the next one.